Hello everyone, welcome to our channel that is 19th Education. So as you all know, we are following with the series of real numbers. So today I am going to explain a little about the real numbers, as I have already explained in my previous video in the detailed explanation of real number, various types of real numbers. So today my main focus is on the properties of the real numbers, but before that, for one who are watching it new, I want to give a little description on real numbers. Real numbers are mainly you can classify it as into numbers. Firstly, real numbers are denoted as R, and here they are classified into two types. One is rational, okay, and other is irrational. Okay, here rational numbers are denoted as Q, and here the example of rational numbers is like root 9, okay, root 9, root 25, and 1.25 or 1.212121. Okay, the example of irrational numbers are root 2, okay, 1.2, 1 2 1 1 2 1 1, the one with the non-terminating, okay, so on. Next, the rational number are further classified as, okay, they are further classified as the non-integer rational number, non-integer rational number, or the integers. Okay, further these integers are classified as you all know, integers are nothing but whole number plus negative integers or negative numbers, okay, numbers, or the negative number. Okay, further this whole number is nothing, consists of 0 and the natural number. Here why I am writing this is we need to maintain this chain. Okay, we need to understand this chain. Here we'll have both -3, -2, okay, -1, 0, 1, 2, 3. Okay, here we will have minus values, -3, -2, -1. Here we'll have 0. Here we'll have from 0 to 1, 2, 3. So here you need to understand the various types of numbers comes in a hierarchy and make a real number. Here the non-integer can be a 2 by 3, 4 by 5, like this. Okay, and in the real number we have some additions of number, that is e, epsilon value, pi value, etc. Okay, so this all comes together and make a real number. Okay, next we will see what are the various properties that apply to these real numbers. Okay, let's see. The first we'll see about the various properties. First is commutative property. Okay, real numbers satisfy commutative property. We'll see under what condition. Suppose we have real numbers like a, b, and c. Okay, these three are real numbers. We are applying commutative property of addition. Okay, we are applying commutative property of addition, so they satisfy. For a plus b equal to b plus a. Okay, for a plus b equal to b plus a. Take an example. If a is equals to 2 and b is equals to 3, we'll submit this a equal to 2 and b equal to 3 both the sides. So 2 plus 3 equal to 3 plus 2. So here 5 equal to 5. It means the addition satisfy the commutative property. Now we'll see with the multiplication. So multiplication is m into n equal to as we have considered a into b. So a into b is equal to b into a. So same, we'll take the same example. Okay, we got 2 3s are 6 equals to 2 3s are 3 2s are 6. So it also satisfies the multiplication. So we can say that in the real numbers, the real numbers satisfy both addition commutative property and multiplication commutative property. Next we'll see the associative property. In the associative property, let us consider a, b and c are three real numbers. Okay, real numbers. Okay, then let's see, a equal to 2, b equal to 3, okay, c equal to 1. So the general form of associative property is a plus b plus c equal to a plus b plus c. Here the major difference is of the bracket. Okay, nothing else, everything is in addition. Now submit the example value here. 2 plus 3 plus 1 equal to 2 plus 3 plus 1. 2 plus 4 equal to 5 plus 1. Here 2 plus 4 is 6. Here 5 plus 1 is 6. So the addition here we can say that the associative property satisfy the addition. So the real numbers can be additive, can accept the additive associative property. In a similar way, we can go with the multiplicative. Why I am not showing with the subtraction and division? Because it doesn't support the subtraction and division. I'll take you an example of subtraction. Let's see with the subtraction. A minus b minus c is equal to a minus b minus c. Let's see whether this associativity can be accepted in the subtraction. See, 2 minus 3 minus 1 equal to 2 minus 3 minus 1. So 2 minus, here it will come 2, here minus 1 minus 1. Okay, here 0, here minus 2. So it doesn't satisfy the subtractive associative property. In the similar way, it doesn't satisfy with the division. In the previous case also, it doesn't satisfy with the subtraction. As you can see 2 minus 3 equal to 3 minus 2. Here we'll get minus 1, here we'll get plus 1. So it doesn't support the subtractive commutative property. In a similar way, it doesn't support the division also. Okay, so now we'll check with the multiplication. Okay, here m, again I wrote m, sorry. Okay, a b c equal to a b c. Okay, 2 into 3 into 1 equal to 2 into 3 into 1. First we'll solve this 2 3s are 6 into 1 into 3, right? 6 equal to 6. So it satisfied the multiplicative. So it means real numbers in both the cases can accept the additive associative property and multiplicative property. Whereas in also commutative also they support addition and multiplication for commutative property, and for associative both they support addition and multiplication. Next we'll see the third one is distributive property. So again we are taking A, B, C as three real numbers. So the distributive property is written as A B plus C equal to AB plus AC, and in other case it is written as A plus B into C is equal to AC plus BC. So here let's see example 1, B equal to 2, C equal to 4. So 1, 2 plus 4 equal to, for this we are substituting the value. For 1 is A is 1, B is 2, again plus is 1, C is 4. We are just using this one, and with the with A equal to 1, B equal to 2, C equal to 3, we are substituting the values, and we are checking whether the two distributive property of real number will satisfy or not. So 1, 6 equal to 2 plus 4, 6 equal to 6. So here it satisfy. Let's see with this one. Okay, A is 1 plus 2, 4 equal to 1, C is 4 plus B is 2 and C is again 4. So 3 into 4 equal to 4 plus 8. Okay, 3 4s are 12 equal to 12. So the real numbers satisfy both the distributive property. Okay, next we'll go with the last one, that is identity property. You need to be careful with the identity property. It most of the time they ask most of the questions from the identity property. Identity property in the additive case, for any number, for any real number A, if you add 0, it will give you the same real number. This is the additive property. Example of this is, if you add 1 by 2 plus 0, it will give you 1 by 2. If you add 1 plus 0, it will give 1. So to the real number, if you are adding 0 and it is giving you the same answer, then that property is called additive identity property. Next is multiplicative property. Here to any number of real number, if you multiply 1, they'll give you the same answer. Example, 1 by 2 into 1 will give you 1 by 1, 1 by 2. If you multiply 3 into 1, it will give you 3. So this property, the multiplicative property, where we are multiplying it with 1 and getting the same answer, so this is called the multiplicative identity property. So in the real number, it supports commutative property in the condition under the condition of addition and multiplication, and they also support associative property under the condition of, again same, addition and multiplication, and they support both the distributive properties. And in identity property, for additive identity property, if you add 0, they'll give you the same identity number, that is same, again they'll give you the same result. For multiplication, again if you multiply with 1, they'll give you the same number. I hope you have understood the properties, the various rational numbers and the properties of rational number in the detailed explanation. So for more videos and updates, please subscribe to our channel, and if you have any doubt, please do comment us and like our channel and share with your friends and family for more upcoming videos. Thank you.